Right.
Plug it in. Just plug it in.
For A it was.
Okay. Okay. Let's see. Let's see how we did. Okay. For period. It was a little tricky because I didn't rewrite it. For period, you need 1 over b times pi. Did anyone figure out who b was?
1/2.
2 pi.
1/2 is the b.
What?
1/2 is the b for this one. Why? How could we rewrite it?
Oh.
Couldn't we rewrite it? Y equals tangent of 1/2
Minus 0.
x minus
So
0.
C. Oh.
C is 0, B is 1/2. It's okay. That was tricky. I didn't rewrite it for you. I was seeing how it would go. B is 1/2. Now if we plug into the period formula, 1 over B. Someone help me out. 1 over in math. What's the snazzy term for it? That's the number. That's right. But when you're doing 1 over, you're finding the reciprocal, which means, okay? So then flipping 1/2, what do we get?
2.
2. And what is 1 over b? 2 times 2 pi.
4 pi.
4 pi.
Oh, shoot. Why do you multiply by 2 pi instead of pi? Yeah.
Tangent.
That's silly, and I was using what formula helped?
Cosine.
I was using sine and cosine.
Oh.
Sine and cosine, 1 over b times 2 pi. But what are we graphing?
Tangent.
Tangent. Now, if you guys are looking at the board, you probably didn't make that mistake because you were just using the formula.
Yeah.
But maybe, when you get to solving and doing it on your own, you think, period, 1 over b times. Tangent is who?
Good.
Good. Okay. Nice, nice, nice. Good catch. Right? 1 over b times pi. JJ.
Wait, where did you get 2?
You first have to ask yourself the question, who's b? B is the number in front. The number in front is 1/2. 1 over means, flip it. What's the reciprocal of 1/2? 2. So, flip it times pi. Cool. Flip it times pi.
Wait, well, the other one, why did you multiply by 2 pi?
Oh, remember with sine and cosine, it was 1 over b times 2 pi? So I was using the old sine cosine period formula, but we talked yesterday how for tangent, the new period formula is 1 over b times pi. So it was missing. First, vertical asymptote. You take whatever's in the parentheses, and what do you set it equal to?
0. Pi over 2.
Vertical asymptote, match it up. Vertical asymptote, pi over 2. Now some of you might have just been able to look at it and say, 2 is 2, so x must be pi. But you could have also solved. Wouldn't you have multiplied both sides by 2? Some of you might have cross-multiplied. That should have worked as well. But either way, you get the first vertical asymptote at x equals pi. So far, so good? My talking was especially so far, so good? Okay. JJ.
Wait, why did you get pi over 3?
Look up. Find vertical asymptote. Is there a formula? Yes. And what does the formula say? Take the inside. Set them equal. So take the inside. Set them equal pi. So we're plugging in. Does that make sense? Cool. Then we just solve by multiplying by 2. So then, kiddos, everyone else, what should you have done for the next one? Look up. Find point of inflection, POI, maybe you missed that part. Find a formula. Take the inside and set them equal to?
0.
Got it. Take the inside, set them equal to 0, multiply both sides by 2, and x is where?
0.
Good. Now how do we put all this? That. We'll get to the other one in a second. Let's wrap them while we're at it. Point of inflection means put a point. But wait, where is it supposed to go?
0.
X. X is when you solve it. We already know x. What's y going to be?
0.
D. And is there a D in front?
No, 0.
Sweet. So I know y is going to be 0. Also, however, is y going to be 0 in this one?
No.
Okay, so I know I have a point or 0. What else can I put on my graph? Go up. Dotted line. Where?
Pi.
Pi. But tangent needs more pieces. Wasn't there a little category for both of these that said define the others? How do I find, we started with a point, let's do that. How do I find another point? Start at the first and add what?
The period.
Who's the period?
5.
Oh, sweet, so go one and go another one. There we go. How do I get another point backwards? Go 2 pi backwards. How do I find another vertical asymptote? Start at the vertical asymptote and do what?
Again.
Go away 2. Or go away 2. Oh, okay. Then all you have to remember is tangent goes
Every 2.
What?
Tangent goes up.
Oh,
Remember him
tangent.
yesterday?
Oh.
Tangent goes up. Now, if there's a number in front, we know that's a vertical dilation, right? Just, we're not going to go crazy. I could make you find all these in-between points and like actually plot them and then get a really good picture of tangent. But can we just talk about it really quickly? If there's a number in front which stretches it, should we kind of show him more closer to a line? Right? If there's like a 2 in front, or a 3 in front, or a 4 in front, just stretch him a little bit, make it look a little bit more like a line. And then if there's like a 1/2 in front, or a 1/3 in front, kind of make him look a little bit flatter. So if there's something that's making him shrink, you're kind of pushing him in, and he's getting really flat. And then if he gets stretched, just make him a little bit more stretched apart. But I'm not going to really grade on that. All I need you to see is it's going up. Okay? So what do? We go up. We go up. No big deal. It's good enough for me. We go up, we go up. Yeah? We can do another one over here. We can keep doing it all day long. Okay, we gotta stop somewhere. Okay, good. So, kind of unlike sine and cosine, we're not putting a lot on our graph. Not really. We just have 3 things to find, and then we use them and go. So then, over here, what do you guys find for these ones? We're not going to spend as much time talking through why. Let's just try to get them. For our period, 1 over b should have been 1/3 times pi. Period is pi over 3. Take the b, flip it. Reciprocal of 3 is 1/3. For our vertical asymptote, we take this entire inside part, 3x minus pi over 2, and we set him equal to pi over 2. I'm not going to go through all the math, but when you add pi over 2, that'd be 2 pi over 2, which is pi. Then you divide by 3. Oh. X is just going to equal pi over 3. Okay. And then for our point of inflection, we take our whole inside and we set him equal to who?
0.
And when we solve, we add pi over 2, divide by 3. We end up with x equals pi over 6. And we kind of talked about really quickly, to find the point, we need a y, and the y is just going to be, there's a 2 this time in front. There was a 0 in front of him, hence y was 0. There's a 2 in front, there you go. What do? Go put all that stuff in the graph. Last time I started at the point, right? Okay, let's start at the point. Pi over 6. Well, can't we just kind of make a tick mark at pi over 6? Let's try that. This time I made the tick mark at pi. We'll see what happens when I make a tick mark at pi over 6. Let's see if it's good enough. Pi over 6. Then I need to go up 2. We're just going to go by radians on the x-axis and just by numbers on the y. So this will be 2. And I have my point. Okay. Where's my first vertical asymptote? Pi over 3. Come on, my fraction people. How many pi over 6s will be pi over 3?
3.
3 over 3 would be 1 whole pi. I don't want that.
But 3, wait.
Oh, sorry. 3 over 6 would be 1 over 2.
1 over
2 over 6.
Oh.
2 over 6 will be 1 over 3. 1/6 plus 1/6, 2/6, which will be 1/3. If you needed to, you could get a little common denominator. multiply top and bottom by 2, and it'd be 2 pi over 6. You're like, oh, sweet, 2 tick marks. There we go. That's pi over 3. Oh, this is a really squished tangent, huh? How do we get another point?
Move over
I go, wait, who is he again? Pi over 3 is how many pi over 6s?
2 times.
Oh, okay. So we'll go ahead and go 1, 2. That's not very even. Am I putting the point on the axis or up like the other one? Good, up like the other one. It's been shifted up, right? How do I get another? I can go backwards too. We'll stop there, that's enough. Okay. How do I get another vertical asymptote? Move the period, which is 2. So go 2 backwards. If I need to, I could go 2 forwards. And then I just have to remember, tangent goes up. We have to go up to that point before we do our little point of inflection and curve it. This one. Okay, we could go all day. Let's not. Does that kind of make sense, guys? Shifted up. Doesn't have a stretch, so I didn't make it look a lot like a line. Made it still have that little curve in between. But it's not super flat either, so it didn't get shrunk. And everything else, I just got my numbers, and I was able to start with these 2 and then move for my period, and I'm good.
Is it okay if you draw one graph or like a little bit of lines and you have to draw more?
That's okay, as long as you have both vertical asymptotes in the point. Just realize it's going to keep popping. Okay, cool. All right, kiddos, great job on those 2. I know it's a little bit rough, but we talked about a tangent yesterday, all the different pieces of the parent function. We had just talked about the clues and hadn't gotten graphs yet. But remember, tangent, we talked about sine and cosine, how they're super similar. Tangent is going to be super similar to who?
Okay.
That's where we're going today. And then after cotangent, oh, but there's 6. Cosecant and secant. But does anyone remember what I said yesterday about what's going to help us with those graphs and kind of make those graphs easy? Being good at sine and cosine. So let's go into our 4-5 homework. Ooh, that's 4-5 exercises. There we go. Oops. We're going to do this really quickly. Because long story short, if you're getting stuck on homework, some of them are just tricky. Some of them are hard. I throw some hard ones at you. Some of them are hard. Some of them are hard. But the hardest ones aren't really going to help us for 4-6 and getting the main idea. The basic ones are going to help us. Okay? So let's just see if you have the basic idea. Remember, if you get all of them right, what should you be putting in your colored pen on the page?
Happiness.
A nice little check mark, right? A smiley face, something to say like, hey, I graded it with you and it was awesome. And then if you miss stuff, just show me. No shame. No shame. We're finding our weaknesses. You guys are already checking, hopefully. Number 4, vertical translation. That should have been the D, right? Number 12. You took an equation and you were supposed to plug into the formula. Remember, 2 different ways of doing the formula. But 1 over b times 2 pi or 2 pi over b. Question. Their way is gross. Would my way have been easier? What's my way say now? This is sine or cosine. There's a 2 pi. My way would have said 1 over b times 2 pi. Who's the b? Oh, this is like what we did today. 2/3, right? And I say 1 over b just means easy. So sometimes my way is easier. Take the b, flip it, and multiply by 2 pi. They have this nice little formula. They put it all like smushed together, but fine. Anyway, some of you might have gotten stuck on that. Cancel the 2's. Okay. Amplitude. There is a negative, but the negative flips the shape. The number being multiplied is just 1. So you can think absolute value, or you can think the negative is a reflection. I don't want that. I want how high, how low, which is just 1 up, 1 down. That's number 12. Number 18. Super similar. I think my way would have been easier also, right? Look at theirs. Ugh, pi over 10. Anyway, period ends up being 20 when you flip pi over 10 and multiply by 2 pi. Amplitude, number in front, 2/3. We like those, hopefully. Even though they were a little tricky, they were fast. Number 20. Long story short, looking at the 2, This is a horizontal shift. The initial point shifts, and when there's a plus, which way are we going? Left. And guys, I don't even know why that F is there. I think I put a line through it. That's a typo. Ignore him. It's just shift pi units left. Or you can say the initial point is at negative pi. You could have put that also. The initial point is at negative pi. Number 34. Okay, what were you supposed to do on 34? Talk about him, right? Yeah, you're supposed to sketch the graph. Long story short, just sketch the graph. So did they maybe show more than they needed to? Yeah, perhaps. Perhaps. They went ahead and showed two different graphs. You could have, like on one, I think that's gross. I would have probably showed them on two, just even though they might have told you to put it on one. Guys, they're showing all this work in a table. It's good work. It is good work, but we have our way of doing it. So hopefully when you guys went to go graph him, hopefully you maybe looked at it like 0 plus 2 cosine of 2 times x minus 0, right? And you put your different clues in here as far as like your middle was 0, you went up 2, you went down, that's not down 2, down 2. You would have seen that the initial point is going to be 0 and you're going to have a cosine start at the top. You would have had to find your period to be pi. And then you would have cut them into fourths, and so you would have gone ahead and had pi, cut them into half and fourths, and said, yay, middle, bottom, middle, top. That's how we would have gotten it. If you look at the book and you love their table and you want to plug in stuff, kind of like with tangent, you could. You could. Some of you that might be easier, but for most, following the guidelines are probably best. And the long story short of it is compared to normal cosine. Was there a second equation somewhere? Yeah. Oh, there it is. That's the answer. If you had graphed him and compared them, you could have kind of just looked at the equations and said, he only goes up 1 and he's flipped. He goes up 2. That's what all this stuff is. He goes up 1 and he's flipped because of the negative. He goes up 2. That's the difference. And the only other difference would have been the periods. Because this one, when you plug into your period, it's pi. This one, when you plug in, it's pi over 2. So basically this one's been shrunk more, this one's been shrunk only by half, this one's been shrunk by a fourth. That's what all that blah 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 stuff is. Nathan.
This is the negative you can do on
Can you see the other one? Let me do a different color. Remember, negative on the outside is a vertical flip, so that's the math of it. And then what does it do? Cosine usually starts at the, you guys remember? Top. Sine at the center. Cosine starts at the top. So if we flip it, instead of looking like, you guys kind of see the cosine? I don't know how to, cosine, what's going to happen to him? So he's going to start at the, do you see it? Start at the bottom and go backwards. Or
it still looks the same, it's just when you...
Like when you just look at it, you're like, oh, duh, it's a sinusoid. But when you start it, you don't start top, you start bottom. Does that make sense? All right. The next ones are shorter. This was the longest one. Number 44. You were supposed to graph him, right? That was a long story short. So you guys didn't need to show the table. You didn't even technically, maybe you should have shown the key points, but I would be able to look at your graph. And if you did your graph right, I should see these points. So maybe you put them, maybe you just showed them. There's one, there's another at pi over 8, another at pi over 4, another at 3 pi over 8, and another at pi over 2. If you guys did your graph properly, I could see them and you wouldn't even have to write this. Up to you. Number 68, weren't you allowed to use your calculator on this one? Go team. But did anybody have some issues with their calculator? Maybe it showed them a line instead of a nice squiggle?
Yeah.
Guess what?
That's natural.
Yeah, it is, because we're graphing trig. We're graphing trig. One time around a circle in radians. What is it? One time around a circle. 2 pi. What is that as a number? Well, pi is 3.14. So 2 pi. 6.28. Oh, would that fit in like a negative 10 by 10 standard window? Yeah, 6.28, that'll fit, right? Radians will fit in a standard window. Degrees, how many does it take to go all the way around? 360. Is that going to fit in a Zoom standard window, negative 10 by 10? No. So, get out your calculators real quick. Let me show you a trick, okay? Degrees need a whole different window than radians. And to some extent, you could say radians need a special window of their own. So those of you guys that got like straight lines, I actually got a couple questions on it yesterday, which was good to remind me I need to show you this. Dun, 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 computer. If you guys go into your Zoom, there's Zoom Standard, there's Zoom Fit, there's Zoom Square, there's Zoom Box, there's Zoom Decimal to see holes. Anyway, is there anything to do with sine, cosine? Or maybe the more general trigonometry category? Ooh. So, my ones that got lines last night. Long story short, you were in degrees and you were in a radian window. So if you went to radians, you'd see it. However, another way to do it is, you don't want this one. Actually, I want this one for later. Let me get rid of that. What's the equation you guys were doing last night? -4 sine parentheses. Okay.
Oh, it's not that.
Oh.
Minus pi over 3.
Ugh. Good thing we were doing a calculator, huh? Okay. Done. Right now I'm going to put myself, oh, there you go. I'm in degree mode, and I'm going to say Zoom Standard, which is what most of you guys were doing. And you're like, where's my sine curve? I don't see my wave. It's kind of lame. Okay. That's not a good picture of the graph. Why? Degrees say I need 360s and stuff, and my poor little window is only going to 10s. Now, we could change this by hand, or, has anybody tried it yet? We could go Zoom Trig and say, oh, wait a minute, how did it magically, it's not magic, it's math, because degrees need bigger windows. Go check out your window. Now it's going by like 360s. Now, I don't know why the calculator goes 352.5, that's awkward, that's weird, whatever. Whoever programmed it was like, I'm going to trick everybody out. But long story short, it's close to 360, right? So it's going by 360s, and if you guys notice, why would it go by 90s on the tick marks? 90, 180, 270, 360, oh, quadrants, right? Now, for those of my guys that were in radians to begin with, why did the Zoom Standard work? Because radians are small. They measure things small. So if you were in Zoom Standard, you were in radian mode, you would have seen it and it would have been even prettier. But let's see what happens when you do Zoom Trig, okay? Zoom Trig number 7. Does it change it? Oh, it does. How? It sees how high, how low from your equation, basically, and then it goes to the window, and it says, why on earth is it 6 point something? 2 pi. Yeah, it's going by 2 pi's instead. And why on earth, wait, who on earth is 1.57? Maybe it's going by pi over 2's? Ish? You can type in pi to your window. Oh. No, I don't know why it's not 6.28. Weird, awkward, some programmer somewhere was like, haha. Anyway. There we go. Is that better with your calculator, my cool kids, especially those that got lines last night? All right. There's a cool Zoom. It's called Trig. It'll help out. Number 76. I think you guys were supposed to get the graph, weren't you? Or was it from the graph? No, it was from the graph. This is the one like we did in class yesterday. We need to finish this up quickly, but we're close. Aren't we close? I put a picture of the problem because he was tricky. Did anybody get a little bit messed up on 76? Got it? Oh, you didn't? I took it out. Uh-oh. Was he hidden? Let me go double check.
He was in there.
Oh, sorry, kid. He was in there. He was hiding. But thank you, because sometimes I do accidentally steal too many. Kiddos, you had this. You were supposed to get that. What do you start with? General, we wouldn't have written it like that. What would we have written it like? Come on, you did it yesterday. Did they say cosine again? Okay. Some of you, just because I heard some people talking and they asked me questions, some of you get stressed about this. Don't get stressed by it. Remember, it's just letting us take out something if it's not given to us in the form that we want. But long story short, it's just a number. Don't worry about the fraction. Makes no difference. It's just a number for the initial point, okay? All right, what'd you guys find? My ones that worked on this in homework, what'd you find as your D or your middle?
3.
Why? Because it was halfway in between. -1, -2, -3 is in the middle. So that's why we can plug in a -3. How high, how low did your wave go? 1 up, 1 down. Did you get it?
Yeah.
Okay, 1 up, 1 down. So we have our +1 cosine of, okay, remember, I don't like period. We'll come back to him. Where did it start? Initial point. Ugh. Where does cosine usually start? At the top. So you could have chosen, and both would have been right, guys. There's not just one right answer. Which one did you choose? Left pi or right pi? Both of them are at top.
Right pi.
Right pi? Okay. So that would be x minus pi. But if you put x plus pi, you're right as well. Still a top. And then we need to figure out period. Well, remember, we'll figure out how long this cycle goes, and then we'll set that equal to 1 over b times 2 pi. Yeah? So how far does it go? Well, oh, this is easy. It goes 1 pi and 2 pi. Sweet. Period was 2 pi. Did we need a b? Was there any sort of change? No. So b was what? Cool. Plug and chug. Is that exactly what they got?
We got -1.
Oh, they're just kind of writing it in a weird way. Anyway, you could look at the amplitude, you could get, no.
Oh, it's reflected in the
Yeah,
x-axis.
isn't it reflected? It's a negative column. Also, it's not at the bottom.
Depends how you put it. Did they give you an equation for it? So technically A would be a positive one. I don't know why they did. They put negative, I see what you're saying, Jason, like start at the bottom, it's upside down. But remember, amplitude's absolute value. We're just saying how high, how low. So I would have put amplitude as 1, but if they're trying to say what's in the equation in the A spot, I suppose you could say -1 for what they did. But the way I did it, it was positive. So +1, anyway, long story short, +1 would be fine. Okay, equals -3. I didn't know which one to choose. So D is -3, but I'm letting you know that A could have been a positive one. Actually, I kind of like that one better, but. You're right, Jason. You could have done it upside down and put a negative just if it's amplitude. All right. I'll let you guys check these last two, 82 and 86. We'll talk about 90 just for a second. 82, it seemed tricky, but literally they gave you y1, y2. Isn't this graphing in your calculator? y1 is your first equation, y2 is your second. So you were just putting in your grapher, and if you're asking where they equal, guys, how do we do that in a grapher? Where they equal, they intersect. Just use the intersect feature. And guess what? It was -3.14159. Who's that?
Pi.
And then it was 3.1415. So that's why they were able to get the negative pi and pi. Remember 86. You have no say what's going on. I would have put the put the +2 in front. I would have put 2 + 3. They wrote it weird and backwards. But you could have done 2 + 3. You could have also put that 1/2, pulled it out. You could have had 2 + 3 cosine of 1/2 x minus pi over 2. That would have been like our way of writing it with our nice nifty clues. And then last but not least, remember number 90. It's never anything that you're going to see on the test, but it was using those little formulas I showed you yesterday with the heartbeats, etc. So then for the first question, you were just finding the period. For the second question, you were flipping the period, but you had to change the units, which is why there's a little extra 60 seconds per minute. Because you had to change the seconds per minute. Some of you might not have realized that. It would have been 5/6, but you would have had heartbeats per. That would have technically been your answer, and since they wanted per minute, that's why they had to build a bridge to go ahead and get it into per minute. All right, kiddos. 15 more seconds. Notes, let's go back. Let's figure out cotangent. Notes, let's go back and figure out cotangent. I'm not sure if we're going to finish secant and cosecant today,
So does that mean the homework's due not
but let's
tomorrow?
see. We won't be grading homework tomorrow, I can tell you that.
Okay.
We won't be grading homework tomorrow. We'll be grading it on Monday, but we're not spending a whole nother day on 4-7-6 either. We're not spending a whole day on 4-6 tomorrow, but homework will be graded on Monday.
Guys, how many sections are in chapter 4?
8,
Oh.
but we're not really doing much in section 8. We're doing just like a little bit just to say like, hey, word problems with triangles again. That's it. So really 4-7's the end. And the nice thing is, guys, this section 4-6 finishes the graphs for us. It finishes the graphs, which is nice. All right. I'm not going to go super crazy. I just want to show you the key stuff for cotangent. And let's transform it and see how it's similar to tangent, okay? So, cotangent, focus. Cotangent, we still use the points 1, 0, 0, 1 to kind of help us. Just for the beginning, just for us getting the graph the first time for the parent function. Cotangent of 0 is 1 over 0. It's flipped. So where tangent is 0, cotangent, he's undefined. 1 over 0, that's undefined. But tangent at pi over 2, sorry, I wrote what I was saying. Tangent of pi over 2, that was undefined, but cotangent of pi over 2. Since you flip it and do x over y, cotangent of pi over 2 is actually going to be 0. So it's like they switch positions. Where tangent was 1, cotangent will be the other. Where tangent was the other, cotangent will be the 1. Yeah.
Do you mean? Oh.
You see it?
Well,
Now, if we were to do 1 in between, real quick, pi over 4.
1.
Oh, the reciprocal of 1 is 1. So that one stays the same. But the locations of these change. So let's see what that actually does in our graph. At 0, where tangent had a point, cotangent has a vertical asymptote. They switch. And at pi over 2, where tangent had a vertical asymptote, cotangent's going to have a point. So they switch. However, pi over 4, if we were to graph them together, pi over 4, they'd be at the same place. So what does this result in? Since cotangent has a period of pi also, you're going to go 1/2 pi and 1/2 pi to 1 full pi. We could go 1 pi over to get his next vertical asymptote. From the point of inflection, we could go 2 tick marks, 2 halves back. Sorry, I put the pi over 4. Maybe I should not put the pi over 4. To get another tick mark, but if you notice, to get from there to there, what do you got to do? Go. Yeah, you're going down. Tangent's going up. Cotangent's going down. Why? Because you flip the point and the vertical asymptote from one to the other, but one point stays the same. Okay. Tangent goes up, cotangent goes down. And pieces are in different places as well. We could put another vertical asymptote if we really wanted to then. So, vertical asymptotes. Stuff kind of changes a little bit, yeah? Vertical asymptotes for cotangent. We're going to have our first vertical asymptote at x equals 0. Vertical asymptote starts right away. And then for all the others are going to be pi away. So all the others are going to be at x equals, remember that ending we used for tangent? We use it for cotangent too. Vertical asymptotes at 0 pi, 1 pi, 2 pi, 3 pi, etc. Why pi? Because it's pi away. And just like tangent, for cotangent, our period is pi. So that's nice. That stays the same. Domain and range, they're squished again. I think I copied and pasted from the other one. OCN. But domain, x just can't be the vertical asymptotes. And range, just like tangent, forever high, forever low. Symmetry. Cotangent actually is odd or has origin symmetry just like. So do you guys see similarities? Super similar. But the vertical asymptote and point flips and the graph goes down. That's it. So then when we get to that whole transformed cotangent, we just have to flip our clues a little bit. Now, if I'm going too fast, why don't you just pause? Let's get the clues down so that you guys have them. And in homework, you can graph any tangent or cotangent. Okay? So, graphing transform cotangent. We're going to start the exact same place that we started in the last one, which is graphing finding our vertical asymptotes. Then we're going to find our points of inflection. And off to the side, we can say our period is the exact same formula, which will be 1 over b times pi. But the nice thing, guys, if the points of inflection and vertical asymptotes literally just split, guess what we're going to do? Take our inside and just flip who we're solving for. For vertical asymptotes, they're going to happen at the zeros. And for points of inflection, they're going to happen at the pi over 2's. Look, it's the exact same equations. They just flipped places. And then how do we find the others? Just like we did for tangent. We're going to add the period. Moving forwards, subtract the period, going backwards. You see how similar? So really, those examples we did for tangent today, it's the exact same procedure for cotangent, except your two little formulas switch from tangent to cotangent as to which one solves for vertical asymptotes, which one solves for points of inflection. And then you just have to remember, go down instead of up. Now, the one thing we're not getting to today, I'm saying it's 1 because it's 2, but it's really just 1, is cosecant and secant. We don't put it in our notes, we'll do it tomorrow. That's why homework is not going to be done until Monday. But what if I was to give you something like 2 plus cosecant of, let's just do no period change, and let's do x minus pi. Wait, I just need you guys to see something. In order to graph this, cosecant, who is cosecant the reciprocal of? Sine. Guess what? I'm not going to show you guys everything, but give me a second. If we go, and if we shift up, and if we move to the right pi, and if we graph our sine, roughly, guess what cosecant is? He just... So if you know how to graph your sine and cosine, cosecant easy, secant easy. We just have to graph one, make it dotted, and bounce. Bye, cool kids. I'll see you tomorrow. Finish up 4-5. You're stuck. You're stuck on some of those other ones. They got hard. Start on 4-6.
I hate you, Ken.
Yeah. So remember, like,
It's all your fault.
one, and then you go.
She said that I couldn't.
It's still all your fault.
Sorry.
Just follow the rules, bro.
If you weren't so bad about giving me the homework pages, this wouldn't be a problem.
Wait, what's the problem?
You. Well, duh.